Hello, and welcome to this Vicon training video. Today I will be focusing on using the various graph nodes for the new Series Transform feature. This video is a continuation of the Part 1 video, which demonstrates how to build transform graphs and how to use the composite nodes. If you haven't watched the Part 1 video yet, you may want to do so before watching this video. For the purposes of this demonstration, I'm using Niagara AX Workbench version 3.7 on my laptop, and I'm running a station on my local machine. In the previous video, I demonstrated how to create this transform graph with 5 history data sources and a composite node. The source nodes are configured to only include history records from the previous week. Resolving the graph displays the collection table with all of the data from the previous week for each of the 5 histories. It would be helpful to also display the total electrical consumption for all the suites on the first floor. However, I don't have an actual electrical meter in the building which monitors all of the suites together. I only have the individual submeter histories for each suite. The aggregate node is designed to handle that very task. Dragging an aggregate node from the palette adds the aggregate node to the graph. I need to break the link from the composite node to the terminal node and relink them through the aggregate node. Now I need to look at the schema for the aggregate node, just like I did in the first video for the composite node. Notice the default timestamp schema is already there, and I can either use the plus symbol or the play button to populate the schema. Clicking the play button automatically populates the schema for the aggregate node using the schema from the composite node that is linked to its transform input slot. In addition to the 5 schema fields from the composite node, it also automatically creates schema fields for sum, average, max, and min values. For each schema field, there's a selector for configuring what manipulation, if any, will be performed on the source data values. Each schema field has a button with ellipses, which when clicked opens a dialog for configuring the function parameters. In the middle section, the function parameter list configures which of the schema fields are included when processing the function. The automatically generated schema fields for each of the schemas from the composite node are set to the default pass-through. This function does not manipulate the source value and simply outputs the raw value for each record. Clicking the function editor in either this dialog or the aggregate dialog allows changing the function. The standard functions include sum, which returns the sum of the records for each schema field selected in the function parameters list, average, which returns the average value of the records from each schema field selected, max, which returns the maximum value of any record from comparing each schema field selected, and min, which returns the minimum value of any record from comparing each schema field selected. Looking at the automatically created schema named sum, I can see the function parameters list includes all of the available schema fields. This schema will essentially be a virtual electric meter showing the total electric consumption from all the submeters for the first floor suites. I will change the name of this schema field to make it more meaningful when it's displayed in the column header in the table. Since these are electrical consumption histories, it probably doesn't make much sense to show the average, max, or min values. If they had been electrical demand histories, then it would make more sense to show the average, max, and min demand values instead of the sum. For this example, I will remove the average, max, and min schema fields. Now I need to look at the schema for the terminal node and probably reorder the schema like I did the first time. Notice the first floor total schema field is included. I will reorder the schema fields to be in suite order number again. Now let's take a look at the results of the updated transform graph. Since the history source nodes have the time range configured as last week, the display data only includes records from the previous week. It is important to note that each individual site column is displaying the raw data values from the applicable history, while the first floor total column is displaying in each cell the sum of the values from the other cells in the same row. Perhaps I don't really need to look at the 15-minute interval data and would rather see less granular data with the results rolled up to only show daily records. The rollup node is designed to handle that very task. Here is a copy of the transform graph that I was working with, but instead of using the aggregate node, I have used a rollup node. The rollup node dialog looks just like the aggregate dialog, with the exception of the rollup interval field editor near the bottom of the dialog. The available time ranges include 5-minute, 15-minute, 30-minute, hourly, daily, monthly, and annually. These selections automatically account for variable length time ranges, such as different numbers of days in a month, or the number of days in a leap year. They also account for a variable length days when observing daylight saving time. The first option in the list is the custom choice. The custom choice uses a relative time field editor to configure the desired interval. In this case, I will change the setting back to daily. Notice the function options are the same as the aggregate node, but the behavior of each function will be slightly different. In the aggregate node, the function processes a single record from each schema field that is selected in the function parameters list. With the rollup node, the function processes all the records from the schema field that fall into the rollup interval, and includes each schema that is selected in the function parameters list. For example, since this schema is one of the source histories collected at 15-minute intervals, and the rollup interval is configured for daily, the sum function will add all 96 records from each day in the dataset to calculate daily values. When using pass-through with a rollup interval, it will simply return the value of the first record in the rollup interval. Now, let's take a look at the results of this transform graph. Instead of seeing 672 rows of 15-minute interval data, there are only 7 rows of data, 1 row for each day of the week, and the timestamps are from the previous week because of the time range configured on the history source nodes. It is important to note that each individual suite column is displaying the total electrical consumption for that day in the cell, meaning the sum of the 96 records from the 15-minute interval data. Each cell in the first floor total column is displaying the sum of the cells in the same row from each column, because its function parameter list includes all of the source schema columns. In this graph example, I'm only using a single data source. In the composite, I've used the same data source twice, which is perfectly valid. They just need to have different schema names. Notice, for each of the numeric schemas from the node that is linked to the scale node, there is a field editor to enter a scale value. All of the field editors default to a value of 1, which applies no scaling. If the prorated value schema represented a common area electrical meter and there were 10 tenants in the building, I could enter 0.1 as a scale factor, so the resolved graph would show values which were 10% of the raw values. Let's take a look at the graph now. Notice the scale value in the prorated value column is 1/10 of the values of the Suite 110 HVAC column, even though the same data source is used for both columns. Another use case might be to enter the inverse of the square footage of the area served, so the resolved graph would show kilowatt hours per square foot. In summary, a transform graph requires at least one data source node and a terminal node, although it's more likely that transform graphs will be more complex with multiple data source nodes and other nodes for manipulating the data. The aggregate node uses functions which create virtual data sets from the source histories. The function takes one or more parameters, which are the source histories, and process functions such as sum, max, min, or average on the record from each of the configured data sources. The rollup node is very similar to the aggregate node in that it also uses functions to manipulate the raw data. It also provides the ability to roll up records in each source data set to visualize the data in less granular intervals than it was initially collected. The scale node manipulates the raw data values by simply multiplying the values by the configured scale factor. Thank you for taking the time to watch this video, and be sure to watch the next video, which covers using transform graphs in PX views. Also, stay tuned for additional Vicon training videos on other new features and changes in the Niagara AX framework.